Okay, ladies and gentlemen, let's look at question 32 on the final exam review for College Algebra, Math 1105. Suppose I gave you a function, p of t equals 50,000 times e raised to the 0.045 t power, and I told you that this function was measuring t representing the time in years and p of t representing the amount of money that you have in a certain account that you set up that was growing according to this formula. Part A asks you the question, how much money is present initially? Now, what I always teach my students, anytime you see initially, you're at the beginning of an experiment, or in this case, you're at the beginning of time. So time is 0. So to answer that question, I'm going to find p of 0, which means I'm going to this function, 50,000, I'm writing 50,000 e to the 0.045 times 0 power. This becomes 50,000 e to the 0 power. E to the 0 power is 1. So 50,000 times 1 is $50,000. So that means that we initially had $50,000 in this account. That's what we put into it. Now, part B says, how long will it take for this money to double? Well, of course, double means times 2. Well, 50,000 times 2 is $100,000. So what I want to know is how long it will take this money to reach 100,000. And here's how I figure that out. My formula says P of t is equal to 50,000 times e to the 0.045 t power. Hey, Zeusy, you're in the guest room. Behave. Mommy would kill us if she knew we were in here. She's going to see the video. Hush. If she saw you up on the guest bed, she would have a cow. And the rest of you in here better not make any messes. Okay, here we go. P of t is 100,000. So that's what I put in. And that's equal to 50,000 times e to the 0.045 t power. Now, to solve this exponential equation, first thing I'm going to do is divide both sides by 50,000. That would give me 2 is equal to e raised to the 0.045 t power. Now, what's kind of cool about this problem, we have Euler's function here, correct? Euler's function? You know what function is the inverse of Euler's? It's the natural log. So, if I very cleverly take both sides of this equation and put it into the natural log function, I end up getting that the natural log of 2 is equal to the natural log of e to the 0.045 t power. This side right now is the natural log of 2. Okay, look what happens over here. Because the natural log function and Euler's function are inverses of each other, when you compose them, they virtually disappear, just leaving you with the initial input. So my answer over here is 0.045 t, and that's due to the fact that I have inverse functions, namely natural log and Euler's. Now when I divide both sides by 0.045, I get my answer to t. And hang on with me. Okay, I need a calculator because you want to approximate your answer. So I'm pushing natural log. Let me clear this out. I'm going to take the natural log of 2. Well, my calculator's not doing very well right now. Let me come over here. Okay, I'm going to take, oh, my calculator's messing up on me. Okay, let me try it again here. calculator's giving me some problems. Okay, I'm taking the natural log of 2 and dividing it by 0.045, and that works out approximately to 15.4. So I'm going to say approximately 15.4 years. That's how long it would take our money to double if we had it invested in the way that this formula implies. Okay?